Here we want to find the derivative of y equals 7x minus 16 raised to the fifth. So here we're going to use chain rule, and here's why. Let's think about this as a composition of functions for a second. So if we have f of x equal to x to the fifth, and g of x equals 7x minus 16, the composition of these functions then would be putting g of x into f of x, we'd have 7x minus 16 raised to the fifth. So there it is. It's a composition of f of x and g of x. So to use the chain rule is f prime of g of x times g prime of x. So we take the derivative of the whole function. We want to think of it as just like x to the fifth. Take the derivative of that multiplied by the derivative of the inside. So I have 7x minus 16 raised to the fifth. So I'm going to take the derivative of the whole function. So just like use the power rule. This is going to become 5, because it's just a 1 out here, times 7x minus 16. 5 minus 1 is 4. Times the derivative of the inside of the function, which is going to be the derivative of 7x. The derivative of 7x is just 7. So 5 times 7 for the outside here. So I do 5 times 7, which is 35. And then we have 7x minus 16 raised to the fourth. So the key with chain rule is making sure that you take the derivative of the whole function. So if you'd like to think about this as just like a single term of like x to the fifth, take the derivative, so it becomes 5x to the fourth. But really x here is the composition of the function, so x is really 7x minus 16. So then you would want to replace that with 7x minus 16 raised to the fourth, and that times 5. And then the g prime, where did I write that? G prime of x. It's taking the derivative of that, so times 7. So that's how we take the derivative using the chain rule. There it is.